Why big tech wants to build AI data centers in space. Imagine a future where the internet doesn't just live on Earth, but orbits above it. Where the world's most powerful apps aren't running in secret warehouses in the desert, but on satellites powered by the endless energy of the sun. Sounds like sci-fi? It's not. Google, SpaceX, and a swarm of startups are now racing to build the first AI data centers in space. Why? Because our planet can no longer handle AI's hunger for energy. This is the story of Project Suncatcher, and the cosmic gold rush to take artificial intelligence off the planet. Where does your data live? Every photo you upload, every AI answer you get, every video you stream, it all happens here. Inside data centers. The beating hearts of the digital world. Each one holds thousands of computers that never sleep, processing, storing, and sending data across the planet. But they come with a cost. In 2023, data centers consumed 1.5% of all global electricity. That's more than the entire country of Spain. They also used millions of liters of water each day just to stay cool. And with AI booming, things are spiraling fast. Training a single large AI model like GPT-4 or Gemini can use as much electricity as a small town for a month. Goldman Sachs predicts global AI power demand could rise 165% by 2030. That's the equivalent of adding entire countries' worth of new power plants, just to run algorithms. And guess where most of that power comes from? Fossil fuels. The very thing AI was supposed to help us move beyond. The problem, and the space solution. Big tech knows this can't continue. They've tried solar, wind, even experimental small nuclear reactors to power their AI. But land is limited. Water is vanishing. And Earth's ecosystems are under pressure. So now, they're looking up. Into space. Because up there, the sun never sets. There's no night, no clouds, no storms, just permanent sunlight and infinite room to expand. And that's where Google's secretive Project Suncatcher comes in. Google engineers testing satellites, deploying solar panels in orbit. Project Suncatcher is Google's bold new plan to take data centers into orbit. Tiny satellites, each carrying advanced AI chips, will circle the Earth in a synchronized network. They'll communicate with each other, share workloads, and beam data back down to ground stations in milliseconds. Their energy source? Pure sunlight, collected by solar panels that are up to 8 times more efficient than those on Earth. In space, there's no atmosphere to block light, meaning Google can harvest power 24/7. By 2027, Google plans to launch its first 2 test satellites, the opening step toward a floating, AI-powered cloud above the clouds. Satellite the race to the stars, and Google isn't alone. Elon Musk's SpaceX is already building data hubs using Starlink technology, turning its satellite internet network into an AI backbone. Startups like StarCloud are teaming up with NVIDIA to send GPU clusters into orbit. Think of them as floating AI supercomputers. Another player, Lumen Orbit, is designing edge data centers that process data directly in space, reducing lag and cutting Earth's energy costs. Analysts estimate the in-orbit data center market could be worth $1.77 billion by 2029, and a staggering $39 billion by 2035. This is becoming the next trillion-dollar frontier, space computing. The challenge is, but it's not all sunshine and stardust. Each rocket launch releases hundreds of tons of CO2 into the atmosphere. So, ironically, launching clean energy projects can start dirty. Then there's space radiation. It can fry electronic chips in seconds. Google has already tested radiation-resistant AI processors, and some survived, but scaling this tech is expensive. And perhaps the biggest danger, space debris. There are already more than 36,000 trackable objects orbiting Earth, and millions of smaller fragments. Every new satellite increases the chance of collisions that could create catastrophic debris storms, trapping future missions for decades. The future math still, the numbers are shifting fast. What costs $1,500 per kilogram to launch today could drop to just $200 by 2035, thanks to reusable rockets and private space competition. If that happens, building and maintaining AI servers in orbit could become not only possible, but profitable. A self-powered, radiation-shielded web of machines circling Earth, crunching data for humanity 24/7. The big question so, is this the future of AI, a literal cloud in space? Or just another tech fantasy destined to burn out in orbit? One thing's for sure, the race to power artificial intelligence has already left the planet. And whether it ends in a clean digital utopia, or a new kind of space pollution, will depend on how far we're willing to go to feed our machines. Because in the end, the future of intelligence may not be built on Earth, but above it. Globe sparkles.